Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive guide on implementing caching with Redis in your nestjs application. This will cover everything from setup to more advanced caching strategies. Table of Contents. 1. Introduction to caching and Redis. 2. Setting up your nestjs project. 3. Installing necessary packages. 4. Configuring Redis. * Local installation, optional. * Using a managed Redis service, example Redis Cloud. 5. Connecting to Redis in nestjs. * Using Cache Manager with cache-manager-redis-store. * Direct ioredis integration, advanced. 6. Implementing basic caching. * Caching controller responses. * Caching service layer logic. 7. Cache invalidation strategies. * Time-based expiration, TTL. * Manual cache invalidation. * Tag-based cache invalidation, advanced. 8. Advanced caching techniques. * Cache aside pattern. * Cache stampede prevention. 9. Error handling and resilience. 10. Testing your caching implementation. 11. Monitoring and performance considerations. 12. Complete code example. 13. Conclusion. 1. Introduction to caching and Redis. Caching. Caching is a technique to store frequently accessed data in a temporary, high-speed storage location, the cache, to reduce latency and improve application performance. Instead of repeatedly fetching data from the original source, example a database or external API, the application retrieves it from the cache, which is significantly faster. Redis. Redis, Remote Dictionary Server, is an open-source, in-memory data structure store, used as a database, cache, message broker, and streaming engine. It's known for its speed, versatility, and support for various data structures, strings, hashes, lists, sets, sorted sets. Because Redis stores data in memory, it provides very low latency, making it ideal for caching. 2. Setting up your nestjs project. If you don't have a nestjs project already, create one using the nest CLI. 3. Installing necessary packages. We'll use Cache Manager for a more abstract caching layer and cache-manager-redis-store to connect Cache Manager to Redis. Alternatively, you can use ioredis directly for more control. * At nestjs/cache manager, nestjs module for caching. * Cache Manager, abstract caching library, supports multiple stores. * Cache Manager-redis-store, Redis-store adapter for Cache Manager. * Redis, official JavaScript Redis client, we need at least one Redis client. * ioredis, alternative and often preferred Redis client with better performance and features. 4. Configuring Redis. You have two main options for Redis. Local installation, optional for development, you can install Redis locally. Mac OS, using Homebrew Brew install Redis and then Brew services start Redis. Linux, using apt sudo apt update, sudo apt install Redis server, sudo systemctl start Redis. Windows you can download a pre-built Redis binary or use Docker. Search for Redis Windows installation. Using a managed Redis service, example Redis Cloud for production, it's highly recommended to use a managed Redis service like Redis Cloud, AWS Elasticsearch for Redis, or Google Cloud Memory Store. These services handle scaling, backups, and maintenance for you. Sign up for a Redis Cloud account, or your preferred provider. Asterisk create a new Redis instance. Asterisk note down the host, port, and password, if any. You'll need these to configure your nestjs application. 5. Connecting to Redis in nestjs. We'll explore two approaches, using Cache Manager, easier, and direct ioredis integration, more control. 5.1. Using Cache Manager with cache-manager-redis-store. This is the recommended approach for most use cases. 1. Import and configure the cache module asterisk in your app module, or a dedicated module for caching. Import the cache module and configure it to use the Redis store. 2. Create .env file asterisk. 3. Inject the cache manager asterisk in your controllers or services. Inject the cache manager using @inject, cache_manager. 5.2. Direct ioredis integration, advanced. This approach gives you more control over the Redis connection and operations but requires more manual handling. 1. Install ioredis asterisk. You should already have it installed from step 3. 2. Create a Redis service asterisk. Create a dedicated service to manage the Redis connection. 3. Register the Redis service asterisk in your app module, or a dedicated module. Import the Redis service and add it to the provider's array. 4. Inject the Redis service asterisk in your controllers or services. Inject the Redis service. 6. Implementing basic caching. 6.1. Caching controller responses. The examples above already demonstrate caching controller responses. Here's a summary. Asterisk check the cache asterisk before calling the service. Check if the data exists in the cache. Asterisk serve from cache asterisk. If the data is in the cache, return it immediately. Asterisk cache the result asterisk. If the data is not in the cache, call the service, store the result in the cache with a TTL, time to live, and then return the result. 6.2. Caching service layer logic. You can also cache data within your service layer. This is useful for caching frequently accessed data that's not directly tied to a specific controller route. 7. Cache invalidation strategies. Cache invalidation is the process of removing or updating cached data when the underlying data changes. If you don't invalidate your cache, you risk serving stale data to your users. 7.1. Time-based expiration, TTL. This is the simplest strategy. You set a TTL, time to live, when you store data in the cache. After the TTL expires, the data is automatically removed from the cache. We've already used this in the previous examples. 7.2. Manual cache invalidation. You can manually remove data from the cache when you know the underlying data has changed. This is useful when you have an event that triggers a data update. For example, when a user updates their profile, you might want to invalidate the cache entry for that user's profile data. 7.3. Tag-based cache invalidation, advanced. This strategy allows you to group related cache entries together using tags. When you invalidate a tag, all cache entries with that tag are removed. This requires more complex implementation, potentially using a custom data structure to track the tags. This approach isn't directly supported by Cache Manager, you'd need custom logic. Here's a concept, you will need to adapt the code. 8. Advanced caching techniques. 8.1. Cache aside pattern. This is the most common caching pattern. 1. Check the cache asterisk. When an application needs data, it first checks the cache. 2. Cache hit asterisk. If the data is in the cache, a cache hit, the application retrieves the data from the cache. 3. Cache miss asterisk. If the data is not in the cache, a cache miss, the application retrieves the data from the original source, example a database. Then, it writes the data to the cache for future use and returns the data to the application. We've already used this pattern in the previous examples. 8.2. Cache stampede prevention. A cache stampede occurs when a large number of requests hit the cache at the same time because the cached data has expired or been invalidated. This can overload the original data source, example the database. Probabilistic early expiration instead of setting a fixed TTL, you can introduce a small random variation to the TTL. This spreads out the cache expirations over time. Locking when a cache miss occurs, acquire a lock. Only the first request to acquire the lock fetches the data from the original source and populates the cache. Subsequent requests wait for the lock to be released and then retrieve the data from the cache. For locking, you would need to use a distributed lock mechanism provided by Redis, example using SETX. 9. Error handling and resilience. Caching can improve performance, but it also adds complexity. You need to handle potential errors gracefully. Catch errors wrap your cache operations in try-catch blocks to handle errors, such as Redis connection errors. Fallback mechanism if the cache is unavailable, fall back to the original data source. Circuit breaker pattern if the cache is consistently failing, implement a circuit breaker pattern to temporarily stop attempting to access the cache and prevent cascading failures. 10. Testing your caching implementation. Unit tests write unit tests to verify that your caching logic is working correctly. You can mock the cache manager or Redis service to isolate your tests. Integration tests write integration tests to verify that your caching implementation is working with a real Redis instance. End-to-end tests write end-to-end tests to verify that your caching implementation is improving performance and reducing latency. 11. Monitoring and performance considerations. Monitor cache hit rate track the percentage of requests that are served from the cache. A low cache hit rate indicates that your caching strategy may not be effective. Monitor cache latency track the time it takes to retrieve data from the cache. High latency indicates that your cache may be overloaded. Monitor Redis performance use Redis monitoring tools, example Redis Insight, to monitor the performance of your Redis instance. Cache size be mindful of the size of your cache. If your cache becomes too large, it can impact performance. Data serialization consider the cost of serializing and deserializing data when storing it in the cache. Choose a serialization format that is both efficient and compatible with your data types. 12. Complete code example. Here's a consolidated code example that combines the concepts we've discussed. .env. 13. Conclusion. Caching with Redis can significantly improve the performance and scalability of your nestjs application. By following the steps and guidelines in this tutorial, you can implement a robust and effective caching strategy that meets your specific needs. Remember to carefully consider cache invalidation, error handling, and monitoring to ensure that your caching implementation is reliable and maintainable. Also consider how you're serializing data and how that impacts performance. Good luck.